Hello guys, welcome back to my YouTube channel. If you're new here, my name is Felix the Analyst. This channel is all about growing our data analysis and data science skills, specifically machine learning. And today I was doing some tasks on machine learning. I was doing telecom customer churn prediction algorithm with machine learning. So for this, I sourced a dataset from Kaggle, and I did the normal steps and came up with a model that is 100% accurate when tested with the original data that was used to train, and 94% accurate when tested with new data. So I recorded while doing it. I'll show you how I did it and the codes I used using Google Colab. So by the end of this tutorial, you'll be able to know how to clean data, how to import the data to the IDE using pandas, then how to do some statistics about the data, some visualizations, how to clean the data, to handle outliers, how to split the training and the tests, how to train the model, how to standardize data, and how to test the accuracy score. So remember to like, share, and comment. Until then, let's jump into the video, see how we did it. Thank you. So first we start by importing the libraries. As you can see, I'm using a Google Colab. So you can just use Google Colab instead of downloading an environment. It's free. So we start by importing the libraries that we are going to use to develop this algorithm. So first I import pandas as PD, where PD is just an alias for that. Then I import NumPy. Pandas and NumPy, we need them to deal with the data, to import and deal with the data in table forms. So we also need pyplot, that is from matplotlib. You call it PLT. We'll be using it for visualization. We also need Seaborns with a short form of SNS, also for visualization. Then from sklearn model selection, we'll import train test split. Train test split is used to split the training data from the test data. Then we need the accuracy score. This will be used to measure the accuracy of the model. Then for pre-processing, standard scale, I will be using this to standardize the data to make sure that there are no big differences between the values in the different columns, or other different values. Then also for the random forest, since we are using random forest classification, we have to import the classifier from ensemble. Then for that, I loaded the dataset. You see pd.read, then the path. I had to insert this R here, or you can use double slashes. Then to view the data, we use data.head to view the first 5, and data.tail the bottom 5. Then we also now need to pre-process the data. First of all, we check for mission values. For null values, this data.isna, as you can see, there are no missing values. We also use data.any, data.isna.any to check, and data.any to sum, to show the sum of. But you can see the data has no missing values. Then now we describe the dataset using data.describe to see the mean, standard deviation, and the quartile ranges of the different columns. You can see here we have very huge means, so we need to standardize this data, or also check for outliers. So checking for outliers, actually outliers are numbers that are, what do we call them? They seem abnormal. For instance, you find that a person's age is 65 years, but there was an error in recording, find that the age has been put at 6,500. Honestly speaking, there's no person who is over 6,000 years old. That means it's an outlier. So how do we add all outliers? First of all, we need to visualize this using box plots from Seaborns. So here I plotted box plots for all the columns using the plt.figure, figure says 20 to 15, subplot. Then yeah, I add them plus the X label. So these are the visualizations. You can copy this. I'll provide the dataset so that if you want to try on your own, you can do. So as you can see from the visualizations, we had outliers here for accountant weeks. We also had here we don't have one. We also had outliers, the numbers that are not within the range, the upper limit and the lower limit. These are the outliers, and they can really mess the model. So how do we, here these are the outliers. Now how do we treat the outliers? I replace the outliers with the 5th and then the 5th percentile. Those who are at the minimum level, I replace them with the 9th percentile. And the ones on the higher side, I replace them with the 95th percentile of the data. So how did I do it? I just came and wrote a code. Columns to clip. I wrote all columns. Columns to clip is equals all columns that have outliers. Then I defined now using this for loop for column in columns to clip. I define the lower limit in the 5th quartile and the upper limit is the 95th percentile. Now, so data.column, I created now a new data set with the clipped data. When you visualize, I visualize all of them again to see. As you can see now, we don't have outliers, as you can see. Yeah. So we check data.shape. We have 333 rows and 11 columns. We should visualize the data. Show so many aspects of it. Now the distribution, etc. of the different columns, the churn, etc. After that, now we also did a correlation matrix to show the correlation between the different values. You see data plan, data usage have a high correlation to the churn. After that, we did some few visualizations. So you look at the dependent variables, that is the count of the churn, 1 and 0. For those who are not understanding what churn is, before you forget, churning is where you check whether a customer is likely to continue using a product or not. That is why I'm using a dataset from Telcom. Yeah, this dataset, you can see we have the customers, churn, account weeks, contract renewal, data plan, data usage, customer service call, day needs, day calls, monthly charges, average fee. With such data, you can be able to tell whether a customer is willing to continue being a customer or is willing to stop using the service. That is what we call now customer churn. When it indicates 1, it means that the customer wants to leave. If it's 0, wants to stay. So yeah, we were down here. Yeah. So this is the distribution. Many customers want to remain, only a few want to leave. So we are going now to find the mean value of the independent variable across all the variables. Yeah. So the mean value for 0 at accounted weight is 100, while for 1 is 102, almost the same. The distribution across all the other is also here for trade. There's no large difference actually between the two. So here we are now going to split the x and y variables, whereby the x variables is all other values or other variables except the churn. So what we are going to do is we are going to drop the churn and then define the rest as x value. So data.drop columns to exclude, comma, axis equals to 1. This axis equals to 1, it shows whether it is vertical or horizontal. So here I've defined columns to exclude. Columns to exclude is this one, churn. Then I came and dropped here. I say x is equals to data.drop columns to exclude x1. Y is equals to that churn. So if I were to drop more than one columns, I could have added them here. This is my specification. So let's print the x and y. Come here, let's see the x. We print x. This is our x. Then we print y. This is our y. These are the top 5 and the last 5. Now we have to standardize this data. To avoid, you can see this one is 110, this is 250, this one is 1 and 0. So it will be ambiguous to compare them. So we need to standardize them using standard scalar. So I import standard scalar. Scalar is equal to standard scalar. Then I fit it there. So I use mean and standard deviation to standardize it. Then after we transform x, these are the values we get. You can see there's no large difference in terms of value size. So it is easy now to go on with the model. Same for the y, we did the same. Printed x and y. Now here we have to split the test data from the training data. Normally, so that for you to have a good model, you are supposed to use more data to train it and a few of it to test. So I'm going to use 80% of the data to train and only 20% to split. That is why the test size here is 0.2. Test data is only 20%, that is 0.2. Then I printed here x shape, x train, x test. So we have 3,333 records. We're going to use 2666 to train and only 667 to test. So let's go into train the model. Since it's a classifier, choose a random forest classifier. So a classifier is equals random forest. Then now we train it now. X and y, we got it here. Now once the model is already trained, you want to check the accuracy of the model. So for the model we use accuracy score. As you can see, when the model has been tested with its own data, it has an accuracy score of 1. That is when you test the model using the data is to train, it has it's 100% accurate. Then if you use a new data set or other new data from elsewhere, the model is 94% accurate. So you can say this is a very good model to classify. That is it for today. I'll drop the dataset link. You can download it also from Kaggle. You can also use it to build your own model. This can be used in your data science portfolio. So subscribe, like, and be tuned for more. Let us know what you need. Let me know what you need us to discuss next. Thank you. My name is Felix Kyoko, Felix the Analyst. See you soon.